Hello, my dear students. Welcome to ninth Standard Science Online Lectures in our YouTube channel. Myself, R.V. Jambagi. In the last class, we have studied velocity of an object can be changed by changing its magnitude or direction or both. We also studied average velocity, the different definitions, along with some examples. We came to know that average velocity of a moving body may be zero, but average speed cannot be zero. We got the uniform and non-uniform velocities along with few examples. In this session of the lecture, we are studying acceleration, accelerated motion, the part of deceleration or retardation, and if we can, we will take some problems on the concepts velocity and acceleration respectively. Let me begin the lecture number 9. The concept of acceleration. The rate of change in velocity of a body with respect to time is known as acceleration. Acceleration of a body is the rate of change in velocity. The rate of change in velocity of a body with respect to time is known as acceleration. Acceleration is equal to change in velocity of a body with respect to time. Means acceleration equals to change in velocity divided by time taken by the body. It can be rewritten as change in velocity is must. For acceleration of a body, change in velocity of it is essential. Here, change in velocity is given by final velocity of the body minus initial velocity of the body divided by time. For final velocity, we are assigning the symbol v, and for initial velocity it is u. Therefore, a is equal to v minus u divided by t. Therefore, acceleration mathematically written as a equals to v minus u by t. Let us take some examples on acceleration. An overtaking bus increases its velocity. An overtaking bus increases its velocity, that means it is accelerating. Increase in velocity, again it is the change. Therefore, we can take an overtaking bus increases its velocity means it is accelerating. That is the first example. Second example, a rocket changes its velocity as it approaches its orbit. When the rocket approaches into its orbit, then its velocity is changing. That change in velocity is nothing but that body or that rocket is accelerating. I hope you got the fair bit of idea regarding the acceleration is concerned. Let me take one more example here. A car changes its velocity as it moves into a city from highways. Let us imagine a car is entering from highways into the city. In that situation, the car should change its velocity, and hence we can say car is accelerating. Okay. In all these examples, or you may take in such motion of the bodies, the velocity from initial to final values change. that is said to be as accelerated motion. We call the body's motion or object's motion as accelerated motion if the body changes its velocity from initial to final value or final value to initial value. Such motion of the body is said to be the accelerated motion of the body. Note that acceleration is also a vector quantity because it carries velocity in it or change in velocity in it, and hence you may call it as vector quantity. The acceleration is taken as positive. As I already mentioned that a vector can be positive, vector can be zero, vector can be negative. Okay, as I quoted earlier here, acceleration is a vector quantity. Therefore, the acceleration is taken positive if the body is in the direction of velocity. If the body's direction, assume it is like this, if the acceleration is in that direction, then we call the acceleration as positive. If the acceleration, if the direction of velocity is like this but acceleration is like this, and in that situation acceleration of the body is taken negative. So it is taken negative when body is opposite to the direction of velocity. If the direction of velocity and acceleration are in opposite mode, then we say the acceleration of the body is negative. Okay. SI unit is meter per second square. How the SI unit is equal to meter per second square for acceleration? We already defined acceleration A is equal to V minus U divided by T. Okay. So this is change in velocity, you may call delta V, which is indicating change in velocity divided by time. So velocity is nothing but distance by time, and already there is one more time is there in denominator, therefore it can be written as d divided by t square. Acceleration can be equal to d divided by t square, therefore the distance is measured in meter, displacement measured in meter, and time square means here second square. This is how we are arriving meter per second square for the acceleration. I hope you followed this technique. Let us move to the next part, that is uniformly accelerated motion. We defined accelerated motion earlier, that change in velocity of a body with respect to time, then such motion of the body is taken as accelerated motion. Here uniformly accelerated motion means what? If the change in velocity of a body is equal, if the change in velocity of the body is equal in equal time intervals or equal intervals of time, then the body is said to be in uniformly accelerated motion or to move with uniform acceleration. If the change in velocity of a body is equal in equal intervals of time, the changing velocity of a body should be equal with respect to time intervals which are equal. Again, such motion of the body is taken as uniformly accelerated motion of the body. Examples here: freely falling body. A freely falling body is the body which is falling from certain height to the surface of the earth. That is simply freely falling body. In such bodies, the acceleration remains same. Okay, that is why that is taken as freely falling body. That will be discussed in the later chapters. So the example for uniformly accelerated motion is concerned, a freely falling body, an object which is falling from certain height from the earth's surface, that is taken as uniformly accelerated motion. For that freely falling body is concerned, a ball rolling from a slope. A ball rolling from a slope is also an example for freely falling body. In both the cases, we are considering acceleration remain constant. Acceleration remain constant means change in velocity remains constant with equal intervals of time. Therefore, I am considering those as uniformly accelerated motion. Okay. Next example, a cycle moving down from a slope. Yet again, it is also same. A cycle moving down from a slope, even though rider is not pedaling. You people are experiencing in slopes. Whenever you are moving into the slope, you are not pedaling at all. So still you are in motion with some amount of acceleration which is fixed, and hence that is also an example for uniformly accelerated motion. I hope you are following this concept right. Next part, that is non-uniformly accelerated motion. We defined uniformly accelerated motion of a body where the change in velocity is fixed, change in velocity is equal or constant. Okay. For non-uniformly accelerated motion is concerned, you have to change the velocity which is not equal with respect to equal intervals of time. If the change in velocity of the body is not equal, I repeat, if the change in velocity of a body is not equal in equal intervals of time, then the motion of the body is taken as non-uniformly accelerated motion, or it is said to move with non-uniform acceleration. Change in the velocity of a body is not equal, is not constant, then we take the body's motion as non-uniformly accelerated motion. Examples here, a car traveling on a straight road increases its speed in different amounts. Assume a car is moving in a straight path like this, but it is moving with different speeds. So such or different velocities, you may call different velocities, then the acceleration of the car is said to be non-uniform. Similarly, another example here, any circular motion of the body is taken as a non-uniformly accelerated motion. Any circular motion of the object or a body is taken as a non-uniformly accelerated motion because its direction is always changing. Its direction changes continuously. When the body is moving in circular path, assume this from this point the body is moving. So at this point the direction is like this. Again at this point the direction is like this. For this direction is like this, and similarly and so on. At each point of time, the object which is in circular motion changes its direction, and hence any circular motion of the body is taken as the example for non-uniformly accelerated motion. I hope you followed this concept as well. Let us move to the next part, that is deceleration or retardation. The negative rate of change in velocity of a body with respect to time is known as deceleration of the body. It is known as deceleration of the body. The negative change in velocity of a body. Okay, I already quoted that the acceleration can be negative. Therefore, negative acceleration is simply a deceleration, or you may call it as a retardation. It is also called as retardation. The negative rate of change in velocity. Change in velocity of a body with respect to time can be negative. So that is taken as a retardation or deceleration of the body. Let us take some examples for deceleration or retardation. Velocity of vehicle decreases when the brake is applied. When the brake is applied, the velocity of the vehicle decreases. So that is nothing but deceleration of the vehicle. Okay. Similarly, landing of aeroplane. When the aeroplane lands, that during that process it has a deceleration or retardation. When the fan is switched off, again fan is in decelerating mode, and hence it is taken as the example for a retardation. Another example, that is a stone thrown upwards. When you throw a stone upwards, after some time it stops and come back. Okay, that is also an example for deceleration. Whenever you are throwing the stone upwards, that amount of acceleration initially it carries, that is taken as a negative acceleration, and hence it is taken as retardation or deceleration. I hope you got this concept right. Let us solve some problems on the concepts of velocity and acceleration. Let me take few problems here, and in the next class we can discuss some more on that. So first problem, a car has the displacement of 5 km in 5 minutes of time on a straight road. On a straight road, the car has the displacement of 5 km in 5 minutes. Then find its velocity. You have to calculate the velocity of the car. Okay. So let us try to write whatever the things given or data given. Here I will take for a displacement as x, which is equal to 5 km, the displacement of the car that is given, and also they have given the time, that is t equal to 5 minutes. So please try to convert it into second. So 1 minute is equal to 60 seconds. Therefore 5 into 60 seconds, and hence which is equal to 300 seconds. So the displacement of the car on straight road is 5 km and time taken is 300 seconds, and hence velocity v is equal to how much? We know that for a solution is concerned, we know that the velocity of a body is equal to displacement by time. Velocity is equal to displacement by time, and hence it can be written as x by t. Displacement is 5 km and time is 300 seconds, which is equal to, again you can change this k into 1000, 5 into 1000 divided by 300 second, this much of meter and second, and hence 5000 divided by 300. So these two cancel each other, and hence you can left out with v equal to 50 divided by 3 meter per second. Second problem, if a truck has the velocity of 60 km per hour in 1 hour of time along a long straight road, then calculate its distance or probably the displacement. Okay, a truck has the velocity of 60 km per hour in 1 hour of time. So in this problem you our keep in hour only, don't try to convert it into seconds because it is not required. We are calculating the displacement or distance here. Therefore, you keep as it is. Let us try to write those one by one. So velocity of the truck that is given v equal to 60 kilometer per hour, and time is mentioned t is equal to 1 hour. Therefore, you need to calculate the displacement x is equal to how much? We know that the velocity v is equal to x by t. So from cross multiplication you can write v into t which is equal to x. Therefore x is equal to v into t, and hence it can be calculated as x is equal to v into t. V means 60 kilometer per hour, means 60 kilometer divided by hour into 1 hour. Therefore hour get cancel each other, and hence x equal to 60 kilometer. Therefore the displacement of the truck x is equal to 60 kilometer. I hope you got this problem right. So in the next period, we will discuss some more problems. Till then, take care of yourselves. Bye bye.